Okay, so we're going to go to our last page in our guided notes, which is page 9. And the last example that we're going to look at is example 610. 610 can be found on page 126. And you're going to notice that we're going to be looking, this is going to be a pliers, and we want to find the force applied to a bolt that would be used in this pliers and the horizontal and vertical reactions at hinge or pin A, okay? Now, as we look at this pliers, you'll notice that in the illustration here, they give us some dimensions, and they also give us the force that we would be exerting on the handle in order to, come down and compress on a bolt. So to look at this pliers, we're going to actually look at one handle. So we're kind of taking it apart, if you would. We're going to look at one of the handles. And what ends up happening is that this handle with the pin connection right here, if we look, if everything is supported just here, this is actually going to be a simple lever. So if we push up on one end, the other side is going to come down because it's pivoting around that hinge. Okay, so another simple machine application of physics. So again, they want us to find the force that a bolt would see given the application force here on the handle and then the position of the pin. And then we want to also figure out what is going on at the pin, like what is the reaction going to be there. So let's go ahead and kind of simplify this and create a free body diagram. Now, what I'm going to do is I'm going to make my diagram to be just a straight line, okay? As we look, if we put a straight line through A, as you know, we can move forces along their line of action and have the same net effect on the body. So we're going to kind of back FB up a little bit, and then we're going to push the 160 newtons up a little bit to be all on the same line. And then that way they'll be in line with A. So A is going to be right about here. We are going to show FB, which is going to be the force on the bolt. Okay. And then the 160 newtons is going to be all the way out there. And then this is going to be A. We have 30 millimeters from A to the front. And then we have 70 millimeters from A to the application of that force. Now, A is a pin. So A is going to have two reactions. Now, you'll notice that these two forces are going up, right? So that means that A is probably going to have to go down. So I'm going to show AY going down. And then there's going to be an AX. Oopsie. AX. Want to add our convention. No, don't want to forget that. Okay. And now what we want to do is we want to solve for FB, the force on the bolt, and the reactions at that pin. Okay. So using our equations of equilibrium, I'm going to start by using the sum of the forces in the x equals 0. I only have that one force in the x direction. So AX is going to be equal to 0. Okay. Box around that. That is the value of the reaction at that support. Now, if we look, we've got two unknowns in the y again, right? So I'm going to do sum my moments, and I think I'm going to go about A. All right, that's that pivot point. You could go around, point B here at the front if you wanted to, but I'm going to do it around A. And I'm going to then solve for FB times 30 millimeters. And this is going to rotate clockwise, so negative out front. And then I have 160 newtons times 70 millimeters. Okay, and it's going to rotate counterclockwise, so positive out front there. And then I can set that equal to 0. All right, so now my only unknown here is my FB. So I'm going to take my 160 and I'm going to put it to the other side. So I'm going to have negative FB times 30 millimeters. It's going to be equal to a negative 11,200, running out of room, 11,200 Newton millimeters. Okay. Then I'm going to divide both sides. Well, they both become positive right away, right? But divide both sides by 30 millimeters. Millimeters cancel. I'm left with newtons for a force. That is good. So my FB is going to be 373 newtons. Okay. Now, here we can see a mechanical advantage. So we're pushing on the handle with 160 newtons, and we're able to apply a load on that bolt of 373 newtons. Okay, and that's based on these two distances, right? It's the work done. All right, that's one of the things that we need to know. We also now need to find the reaction AY. So I can do my sum my forces in the Y equals 0 now that I know FB. And I know FB is 373 newtons going up minus AY plus 160 newtons, okay, equal to 0. So solving for AY, negative AY is going to be equal to 373 160. So 533, sorry, 533 negative on the other side here. Newtons, because it's positive on this side, we move it to the other side, these both become positive, right? So that means that the direction that we assumed AY for was correct. Okay. And the pin then has to be able to support 533 newtons. And again, that's like, now you would take it to the next level of like strength of materials and determining the size of the pin that would go through there. But that's not a statics problem. The statics part of it is finding out what is the force that's present. Okay, so that is example 610. So now that you have completed, if you would, all of the problems in our guided notes, we would be ready then to start looking at the application problems, as it states down here, for Module 6. So I'm going to stop here, and then we'll resume another video, just kind of going the overview of the actual application problems.